Imagine you weigh as much as 33 elephants. You are the largest animal that has ever existed on this planet. Bigger than anything the fossil record has ever produced. You are 100 feet long, and your heart is the size of a small car. And your entire diet is this. Not fish, seals, or anything you'd expect a creature of that scale to bother with. Just billions upon billions of shrimp-like animals, so small you could hold 100 of them in your fist. On land, predators match their prey. A lion takes down a wildebeest. A wolf pulls down an elk. Size versus size, power versus power. The ocean decided that rule was boring. And the blue whale is the most extreme proof of that decision in the history of life on Earth. Before we answer the big question, let's meet the players. Because the blue whale is not alone in this strategy. Several of the ocean's largest animals have arrived at the exact same conclusion. First, the blue whale, the absolute record holder, the biggest animal to have ever lived, not just in the ocean, but anywhere. It can consume up to 40 million krill in a single day. That is roughly 4 tons of food per day, scooped up in massive lunges through clouds of prey so dense they show up on sonar. Second, the humpback whale. Smaller than the blue, but arguably more impressive to watch hunt. Humpbacks are tacticians. They work in coordinated groups, spiraling beneath schools of fish while blowing columns of bubbles that form a cylindrical net, a living trap that herds prey into a panicked ball. Then they lunge through it, mouths wide open, swallowing thousands of fish at once. This is one of the most sophisticated cooperative hunting behaviors in the animal kingdom. And it works on prey no larger than your hand. Third, the bowhead whale, built for the Arctic. It moves slowly through freezing waters with its enormous mouth held open, filtering copepods, creatures so small they're barely visible to the naked eye. The bowhead is the longest-lived mammal on Earth. Some individuals are over 200 years old. They have been alive since before the American Civil War, and their entire life sustained by creatures smaller than a grain of rice. And finally, a bonus entry that isn't a whale at all. The whale shark, the largest fish on Earth. Not a mammal, not even closely related to whales, but it arrived at the exact same feeding strategy independently. Millions of years of evolution, completely separate lineage, same answer. When the same solution evolves twice in totally different animals, it's not a coincidence, it's a clue. Here is the question that makes this whole thing remarkable. Why would the biggest animal in the history of life on Earth bother with something that small? Think about energy. A lion chasing a gazelle burns enormous amounts of it. Explosive sprinting, physical combat, the risk of injury or failure. It catches one animal, maybe 200 pounds of food. If the hunt works at all, which it only does about 1 in 5 times. Now watch a blue whale feed. It accelerates into a krill swarm, opens its mouth, which is large enough to fit a school bus inside, and engulfs hundreds of thousands of krill in a single lunge. It then filters the water out through its baleen plates and swallows what remains. That one lunge can deliver 500,000 calories. The math isn't close. Filter feeding is so catastrophically more efficient than pursuit predation that once evolution stumbled onto it, scaling up became the obvious move. The bigger you are, the more water you can filter. The more water you filter, the more you eat. The more you eat, the bigger you can grow. The ocean didn't break the rules of predator and prey. It just found a cheat code. Now flip the lens entirely. Because to understand why this strategy works, you need to understand how extraordinary the prey actually is. Krill are small. A single Antarctic krill is about 2 inches long and weighs roughly 1 gram. By individual animal standards, they are nothing. But they do not live as individual animals. Krill form superswarms so massive they change the color of the ocean. Some swarms stretch for miles. Some are so dense they register on naval radar. Scientists have estimated single swarms at over 2 million tons of biomass. That is more than the combined weight of every human being on Earth, packed into one writhing, living cloud in the Southern Ocean. The most astonishing part of this equation is how direct the energy transfer is. Krill are essentially solar-powered. They eat phytoplankton, which are microscopic algae that convert sunlight into energy. That means the food chain that built the largest animal in Earth's history starts with a single ray of sunlight. Sunlight becomes algae. Algae becomes krill. Krill becomes a blue whale. 3 steps. From a photon of sunlight to a 200-ton whale. The whale doesn't need to eat something big. It needs to eat something abundant. And krill are the most abundant multicellular animal food source on Earth. But krill are not alone in this role. The bowhead whale's preferred prey, copepods, are even smaller and even more numerous. Most people have never heard of a copepod. Most people couldn't identify one. They are microscopic crustaceans, smaller than a sesame seed, drifting through every ocean on the planet in numbers that dwarf every other animal combined. The ocean is, in a very real sense, a soup of copepods. And the bowhead whale has built a 200-year lifespan on that soup. To pull this off, these whales needed a piece of biological engineering so elegant it deserves its own moment of respect. Baleen. Instead of teeth, filter-feeding whales have baleen plates, long, flexible keratin structures hanging from the upper jaw, structured like overlapping combs. The outer edges are smooth. The inner edges are fringed into thousands of fine filaments. When a whale lunges into a krill swarm, it engulfs an enormous volume of water along with the krill inside it. Then it uses its massive tongue, the largest tongue of any animal on Earth, to push that water back out through the baleen plates. The water escapes. The krill do not. It is, in effect, the world's largest biological coffee filter. The humpback's approach adds a layer of intelligence to this. Bubble net feeding requires multiple whales to coordinate specific roles. Some blow the bubble curtain, some vocalize to herd and panic the prey. One leads the lunge. Researchers studying this behavior have found that individual whales take on consistent roles within their group. The same whale tends to lead. The same whale tends to blow the net. That is not instinct running a fixed program. That is a division of labor. That is teamwork. Here is how precise the engineering gets. The spacing of the baleen filaments is calibrated almost exactly to the size of the prey. The bowhead's baleen has finer fringing than the blue whale's because copepods are smaller than krill. Evolution tuned the filter to the food source across millions of years in multiple species independently. It didn't just find the strategy, it optimized it. Whales weren't always like this. 50 million years ago, the ancestors of modern whales were land animals. Four-legged, fur-covered mammals that walked the shores of an ancient sea called the Tethys Ocean. They had teeth. They chased prey. They were, by every measure, hunters in the traditional sense. Over roughly 20 million years, these animals moved progressively into the water. Their legs became flippers. Their nostrils migrated to the tops of their skulls. Their bodies became hydrodynamic. And in the lineage that would become baleen whales, the teeth disappeared entirely, replaced by those remarkable keratin plates. They gave up the hunt. They gave up teeth. They gave up chasing. And in exchange, They became the largest animals that have ever existed. Think about what that trade-off means. Every toothed predator in the ocean is fundamentally limited in size by the energy cost of hunting. There is a ceiling. Filter feeding has no ceiling. The more abundant your prey, the bigger you can afford to grow. And the bigger you grow, the more efficiently you feed. The baleen whales didn't give something up. They unlocked a door that no other large animal had ever opened. But here is where the story turns. The most powerful animals on Earth are completely dependent on creatures you would need a magnifying glass to fully appreciate. And that dependency is a vulnerability. Climate change is warming the Southern Ocean, and krill populations are directly tied to sea ice. They feed on the algae that grows on its underside. As sea ice retreats, krill habitat shrinks. As krill habitat shrinks, the swarms thin out. And as the swarms thin out, a blue whale that needs 4 tons of food per day has to work harder, travel further, and eat less. The largest animal that has ever lived is not threatened by anything its own size. It is not threatened by predators or competition. It is threatened by warming water temperature and the knock-on effect that has on creatures barely visible to the naked eye. 2 inches of krill, 100 feet of whale. The ocean connected them, and the ocean can sever that connection. The biggest animal on Earth is not as invincible as it looks. It never was. On land, the rule makes sense. Big hunters, big prey. Power against power. The ocean looked at that rule and built something entirely different. It built an ecosystem where the sun powers the algae feeds the krill, and the krill feeds the largest animal that has ever existed on this planet. In 3 steps, across an invisible chain that spans the entire food web. So here is the real answer to the question we started with. The blue whale is not big, in spite of what it eats. The blue whale is big because of what it eats. Tiny prey, eaten in incomprehensible numbers, is the only thing that could ever have built something this large. The ocean didn't break the rules of predator and prey. It just wrote better ones.